Hello, how do we go about solving this equation? Well, if we note that 4 is equal to 2 squared, then we can write that 4 to the x is 2 squared to the x, which we can write as 2 to the x squared. Likewise, 4 to the minus x, we can substitute as 2 to the x to minus 2. So now we can rewrite our equation, and we can now use y is 2 to the x. So substituting, in the original equation, we have 8 y squared add 1 over y squared minus 54 y add 1 over y add 101 equal to 0. But further to this, in order to simplify this, we can make another substitution. We can let y, or z, sorry, as equal to y add 1 over y. So we can simplify our second equation. So this is the original, and we have here in y, and now we have a substitution with z. So now 2 becomes 8 into z squared minus 54z add 85. And this is equal to 0. And so now we call this equation 3. Now this is part 1 of the problem. I'll be doing 2 other parts and 2 separate videos. Just to recap what we've done, we started off here with the original equation, and I've showed you here how I arrived at the substitution y is equal to 2 raised to the power of x, simply because we can write 4 to the x as 2 to the x raised to 2 all squared, and 4 to the minus x raised to 2, written as 2 to the x raised to the minus 2. So we substitute for y in this equation, in the original equation, and we make another substitution here for z to simplify this. We have z is y add 1 over y. So y squared add 1 over y squared becomes z squared. And here we have minus 54 z. As we simplify this, we have now a constant of 85. So here finally, so remove these brackets, no brackets here, we have our quadratic 8z squared minus 54z at 85. In the next video, I'll be solving for z, and we're actually going to do in the reverse. We're going to solve for z first, then we solve for y, and then finally for x, which is the original unknown. Thanks for watching. I'm Alistair.